Hello everyone, and welcome to this ExpressMarine webinar. Thank you for joining us. My name is Rhino from B&A Software, the developers of the ExpressMarine Rhino plugin. And with me today as panelists to answer your questions in the chat, I have Nick Denise of NDA-AR, Bruce Hayes of ShipWeight USA, and Randy Ficka from B&A Software. Today's topics will be modeling of details, defining volume regions, integration with ShipWeight, stock libraries, color handling and templates, and tips and tricks for effective modeling. So let's start with modeling of details. A few weeks ago we sent out a survey. Perhaps some of you responded to that. And one of the feedbacks from that survey was that many of you want to be able to model more details in ExpressMarine. ExpressMarine is first and foremost a tool for preliminary design, but nonetheless it was a very clear feedback from you. So in the future we will start develop more capabilities to model details in ExpressMarine. That being said, even today there are some possibilities to model details, and I'm going to show an example where I model some brackets to show you how that can be done. So what you see here is the ExpressMarine model, an ExpressMarine model in Rhino. This is of a small vessel. By the way, this model will be made available on our website after the webinar, along with the tutorial if you want to check it out. But I'm going to use this model here as an example on how to model some brackets. I have my ExpressMarine window here, and I'm going to start by turning off the visibility of this shell part here. And also I want to turn off the visibility of this bulkhead, and as an example I'm going to make some brackets in the upper corners here between the shell and the deck. The first thing I'm going to do is define myself a custom group to store these and create these brackets, and I will do that by clicking on the tier 2 node and right click and select add custom group. Next I'm going to select this custom group, right click and say rename, and I will rename this to just call it brackets. And now I just have a custom group, and within this custom group I am going to add X series objects, and I will rename these and call them brackets on the port side of the ship. Now let me move this model a little bit and move this window into the screen a little bit. And let's see. So now we have these brackets here, and to not take too much time, I'm gonna model 3 brackets. So I'm gonna have a bracket here on every frame, starting from frame 10, which is this frame right here, and ending at frame 12. So that's going to create 3 frames for me, or in this case three brackets. And the way I'm going to define this one is to start off very simple and then add more details to get them the way I want them. So first thing I want to do is to set a set limits, and I'm going to do a limit of y larger than 3.5 meters, y less than shell port side. I will do z larger than 2.1 meter and less than the deck plane. To select the deck plane, in case you haven't noticed, there's an arrow next to most all of these limit boxes, whether it's here or within openings or stiffeners. You can click that arrow and then click on the object, and then it will catch the name of that object. So this is the first step, just to limit it like this. This is basically just gonna create a square, and then we're going to take it from there. But let's start with this and click generate, and we see we get squares, sort of squares in here. But this isn't exactly like the way we want to have them, and so the next step now is to make them better by first of all, not let them collide with the stiffeners. As you can see here, these objects have been created according to the limits that were given, and those limits were some numbers and shell and the deck. So it has been created exactly like that. But now we have an overlap between stiffeners and these small brackets, and we want to fix that. And this brings me to a new feature, fairly new feature, that you may or may not have used before, and this is the possibility to specify offset on a limit. If you noticed, next to each of these limits there's a box, plus, and then something empty. This can be used to set offset for the limits, similar to offsets you can set for cutout or a stiffener. So in this case, I know that my stiffeners are 60 millimeters high, so I want to create this now with an offset of, on the shell, put an offset of actually it's going to be minus 0.06 on the deck, and also on the shell minus 0.06, and then I will generate again, and we will see that now these are created not colliding with the stiffeners but aligning nicely to them. So that's the first step. Then the next step, I want to create some use some openings to get these more like the way I want to have them. So I will add one opening to create a radii here and a radius here by defining two openings, and I'll show you how to do it. I'll start with the first one. I go down to cutouts and openings and click plus, and from the templates I'm going to select this type of one big opening, and in here I'm going to call this C1, and I'm going to put the upper border. Again, you'll see we have this arrow, so I can click the arrow and then point to my deck. And I'm going to do an offset of this of 80 millimeters. Then I will have my shell port side, and I'm going to do port side offset of 80 millimeters. And for the starboard border I'm going to put 3, and for the lower border I'm going to put 2 meters, 3 meters, and lower offset of 0, both for and a starboard offset of 0, radius of 300 millimeters up here, and no radius for these other corners. this is my first cutout. And what's going to happen now is that this will affect only this hole is going to be bigger than the plate, so it's going to cut into the plate with the radius like this, as you will see. Confirm. Now if I generate this one just as it is, this is a brute, you will see that this is now actually going to create more realistic type of brackets, as you see. And then the next step here would be to I want to also have a radius here on this end, so I'm gonna create another opening, and it's gonna be a C2, and here I'm gonna put the upper offset of 60 millimeters, and there should be deck 2 plane 1. The shell should also be here, the port side border, and I'm going to do a port side offset of 60 for the starboard border. I'm going to do 3.5 meters, 0.5, and a starboard offset of 220 millimeters, a lower offset of actually for the lower offset here I'm gonna do something a little unusual. I'm gonna select the deck here as the lower border, same as I have as the upper border, but then I'm going to do an offset, a lower offset of minus 120. You can actually specify a negative offset in case that is better suited. So this means that the lower offset now will, if the deck moves, this gonna move along with it, this border and the offset. And then for radii I'm gonna put 0, 0, 40 and 0, and confirm. And when I generate, let's see what happens. We now get these brackets, as you can see, defined here. So it may not be exactly like true brackets like what you would have on true drawings, but at least you will get the weight counted for these now and the center of gravity counted for these. And of course the nice thing here is that with this you can now just extend this to whatever frame you want and create them using the same methodology. Alright, so this was on the port side, but next step would be to see how can we now also get them on the starboard side easily. And unfortunately for these custom objects, we don't have the possibility of just checking symmetry and bringing them over to the other side. So we have to manually create them, but as you will see, this is done fairly fast and simple. Now to get these same brackets on the starboard side, what we can do is simply select this node, and on the sub menu you will see we have cut, copy, duplicate and paste. Let's do duplicate, and then it's going to give us a duplicate, so we can rename this to brackets starboard, rename. And now we should again have from every frame from 10 to 12. And what we have to do now is just reverse the Y settings here and also for the openings. So I'll show you how to do that. So this means that we will have shell starboard here, and we will have minus 3.5 here, and instead of minus 0.06 we will have plus 60 centimeters. That should be fine there. And then we can edit these openings, and again it's this Y we have to I mean on the Y direction we have to just reverse it. So this means that there should be minus 3 here, there should be shell starboard here, should be 0 on this radius and 300 here, it should be 0 here and 80 here, and then we can click confirm. And finally we have to just do the same with this one. Opening here should be minus 3.5, and shell starboard should be 40 here and 0 there, and it should be 220 here and 60 here. Confirm, and then we can click generate to create these. And that's done, and let's zoom out. So let's zoom out and have a look, and this did not look correct. Let's see. Oh, I see. So I have I forgot to move this one over to this side here. Should be here. Okay. Try again. Generate, and there we have our brackets also on this side. So you see, it doesn't take too long to just mirror this. When you have this new functionality here, duplicate, it brings over the definitions, and this duplicate you can use on any objects in ExpressMarine. So that concludes what I wanted to show as far as details, but as mentioned, this is something we are working on for the moment to create more possibilities to create details in ExpressMarine, and we're working on some specific graphical user interface for this. So in the future there will be more possibilities and more user-friendly ways of doing this, but as you can see, it's not entirely impossible to create some details even within the existing functionality of ExpressMarine. Now let's move to the next topic, which is defining of volume region. Now this is a completely new feature that is not directly related to structure, but related to defining volumes. So let's have a look at that. Alright, so let's go back to our model, and as you can see, if I collapse the structure node in ExpressMarine, you will see there is a volume regions node, which by default have 3 volume regions defined: light ship, tonnage and tank volumes. You can right click and add any other volume groups, but some of these have the intent is that these have some special functionalities that can be utilized, and we will now look into defining some tonnage volumes. So I'm going to select create some tonnage volumes, but before that I'm going to define some content colors, and I do that by clicking this define content color which brings up this window, and this will allow me to, for example, define water ballast and then assign certain color to that. This one, for example, and then I can do fresh water and assign another color to the freshwater tank, and maybe I can also do a fuel oil tank type, and also here define color. Now currently these are for the time being just defining colors for the tanks for these contents, but needless to say, we have some further plans for this in future releases, but right now it's just defining colors. Okay, let's see how we can define volumes and how to use these colors. I'm going to select tonnage volumes and right click and say add volume group, and I'm going to call this ballast tanks, first group, and then I go down and select ballast tanks, and I want to add a volume, and I'm going to call this one just tank 1. Okay, now let's do a little zoom in and out here again and move this a little bit here. Alright, so then I select my tank that I've added, and now I'm going to define it. And the way I will define it, first I can select a color for it, or I can select a content. If this was a water ballast tank, then it just select the content type, and then it automatically get the color that we just defined for water ballast. Now the next step is to define limits for this volume, and this is done in the very same way as we define limits for structure, except that now it is volumes. And then there are a few peculiarities, but I will get back to that. So here we're going to get the tank that's going to end, and I'm going to use this arrow again to pick limit. I'm going to find this first watertight floor here, and then I'm going to, for the Y, limit it by the girder in the middle here, longitudinal girder 1, and then on the Z I'm going to limit it the max value for using the deck. Then I'm going to, for the lower Z limit, I'm going to put in the shell. And notice that if I put the shell here, this automatically also will define limits for X and Y in this case. If you're using shell as a limit, it's good to only define it once. Don't define it many places, only use this one. That has to do with the mathematics on how we create the volumes in the background. So there's no need to repeat shell in other places. Alright, so now I click generate, and my first volume is being defined here, as you can see. I can also give it a name. I'll just call it tank 1, same as the description. So I'll leave weight group open for now. And yeah, that's our first volume. We can see the volume here in cubic meters, and volumetric center in X, Y, Z, and also the boundaries of this volume down here. So this was our first tank. Now let's create another one, and let's do it by the same tank on the other side, and that is, let's see, first let's turn off the shell here so it's going to be easier to see. So there's a very easy way of doing that. That's just to right click here again, do duplicate, and I'm going to call this TK2, tank 2, and this now is a copy of tank 1, but to put it on the other side we can go down to transformation and select reflection and generate, and we will have a tank 2 on the other side. So now we have 2 tanks here. Let's make a third one, last example, and then let's make this a little bit more complicated, just to show what we will do when you cannot make a boundary within 3 or within just one boxes like limit like this. Let's go back up here then and create a tank that could be, let's add a volume group and call it, let's say that this would be a fuel tank, so this should be fuel tanks, and then add a volume TK3 name, right? Select that one. This would be a fuel oil tank, and we're going to create this by, let's turn off this one so it's easier. I'm gonna select these 2 watertight floors. This again, I'm going to do deck, and I'm going to do this girder this time, and also here the shell, and generate. Now I have this tank here, and now I want to add something more to this tank. So the way I do that is I right click this tank and I say new addition region. So we can specify addition regions and reduction regions to get more complex tanks. In this case I'm going to do a addition region and go down here, and here I'm gonna do longitudinal girder. Let's copy this, start by that girder, and then go into the center girder, and instead of starting at the back there, I'm going to start my X position at this frame here. Then I go to the top, I generate, and now it creates this tank with this addition. So we have a more complex tank. If I want now to make this a symmetric tank, I can do symmetry, but I need to do, and I could do it just on the addition or on everything. If I do it just on the addition, I go down here, can put symmetry here, go to the top, select generate, and the addition will be symmetric. Then I can also say symmetry on the main part and do generate, and now I have a symmetric tank here. So now we've defined 3 tanks. And let's give this also a name, and this one also a name. So in this way you can continue and create tank volumes for your model. what you will notice is that if you do it under the tonnage volumes, it will automatically calculate the gross tonnage for you based upon the volumes that you define within this node. There's another thing you can do. You can also create a report. If you go to any of your volumes nodes and click make report, it will bring up a user interface that allows you to do some settings. Scanting draft here, let's say 2 meters, height uppermost continuous text 2.4 meters, and the other thing we can leave as is. Click update report, and then it's gonna make a nice report for you with views of the defined volumes, with some simple hull hydrostatics, and a volume table showing you an overview of the volume and in cubic meters, and in also the center of volumetric centers of the volumes that's been defined. Then this report can be also exported to a PDF and sent to a printer, of course, or sent to someone as a small report of the volumes. So this is what I intended to show you about volumes, because going further now is just more of the same. Of course, as mentioned, we could have done some examples with reduction instead of additions, and there are possibilities to refer to previous defined volumes to add something or to deduct something, but these things is easy to explore on your own. So instead we will go to the next topic, which is integration with ShipWeight, which also has a little bit to do with volume regions, as you will see. Okay, to show the integration with ShipWeight, I have prepared a little further. So I'm gonna close this ExpressMarine window and open up another version of the same vessel, where what I've added here are just a few more volumes. And let's see. Sure, just opens up and you will see that it's the same vessel and I have the same tonnage volumes, but in addition I've added some light ship volumes here. So if I turn off the visibility of the tonnage volumes, turn off the visibility of the structure, you will see that I have now defined 4 other volumes here: aft ship, engine area, cargo area, and foreship. And they have been defined just this quite simply by using just limits, not too complicated volumes in this case, 1 for each. But the only thing extra I did after I defined these volumes were that I defined also a weight group for them. So this aft ship, depending on which work breakdown structure you use in ShipWeight, the one I'm going to show now uses the standard one, which has aft ship in weight group H1.1. So that's been assigned to this volume. The same is for engine area H1.2 and cargo area, which is H1.3, and foreship, which is H1.4. So one of the reasons that you want to export this to ShipWeight is at the very early stage, maybe even before you have done any structure at like stiffeners and any details. You can just start by bringing in the main bulkheads, watertight bulkheads, and enough to define the ShipWeight volumes, and then you can export this into ShipWeight and start by doing parametric estimation. Then you can continue with details in ExpressMarine and then export the results of the details from ExpressMarine to ShipWeight and compare the results. Okay, so first step is to define the volumes according to the same volume areas in ShipWeight. And then there's another setting you have to do, but this is something you do only once. And that's go to this node where it says ShipWeight settings, and then you define the ShipWeight parameter IDs for the ShipWeight volumes of the groups, including the parameter IDs in ShipWeight belonging to the longitudinal center of gravities, transverse and vertical center of gravity. This is just doing once, and it's the same on all of your project, and something we can help you set you up depending on which ShipWeight system you use. When that's done, you're ready to export to ShipWeight. And to export to ShipWeight, you go to the project here, and you find this export to ShipWeight tab, and you either get the server list or type in the name of the ShipWeight server to connect. And then the first thing you do is you select the database, and within the database you select the project ID. This is webinar. So I have a project called webinar and a project database called web demo. And now I'm ready to export to ShipWeight, and the only thing you need to do is to say, okay, which should the item number start at if you're doing details, and then you have export of parameters, min-max values, and weight details. And typically you would start by exporting parameters. Just click on that, and then you export min-max values. Click on that, and at the very early stage that's where you would stop. But then later you may want to also export weight details, and I'm going to do it all in once here just to show you. Export weight details, you have to just select, you want to do the playground area in ShipWeight or the main, and what levels do you want to just take the main objects, which means that plates and stiffeners will come in at one object, or do you want to do details, and then which item number do you want to start at. So with that done, you can click export weight details also, and get the details of your structure into, in this case, the playground area. So the export is done, and if I start ShipWeight and open up just to let you see how this would look in ShipWeight after export, I start ShipWeight, and then I open the project. I got it here, webinar, and what you will see is two things. One, the boundaries of the weight groups have been automatically populated into the VCG, LCG, TCG min max, and if I go to parameters and look at volumes, you will see that the volumes from ExpressMarine, including the center of buoyancy, have been automatically exported to ShipWeight. And this means that now you are immediately ready to start doing parametric estimation in ShipWeight on these parts of the vessels, and you have everything you need as far as volumes for weight, and you have the other information, boundaries and center of gravities for the center of gravity estimation. Then typically later you would also export the details, and in this case we just did it, so if I go and open up the playground area, you will see that these are all the items that have been exported from ExpressMarine, and you can compare then the total weight and center of gravity in your model here with the total center of gravity, total weight and center of gravity in the playground area, and you will see that it is exactly the same. So now you have all the items, and you can go further in ShipWeight to create the weight distribution curve and so forth. But this is how easy it is to get data from ExpressMarine to ShipWeight. Now, next topic is stock libraries, color handling, and templates. Okay, so going back to our model here, let's have a look at color handling first. One thing that's been existing for a long time in ExpressMarine is the possibility to change from object-oriented coloring to layer-oriented, and by default ExpressMarine is showing color according to object type. So any bulkhead has green as a default color, decks have dark orange, and stiffeners have red. These can be changed if I select the deck here, for example. Then I can go to this particular deck plane and change the color from dark orange to something else. But sometimes you'd like to, instead of doing colors per object type, rather have stock type. If we look at the layers in Rhino in an ExpressMarine model, you will see that ExpressMarine is creating plate layers for each type of plate, and it also creates a stiffener layer for each type of stiffener, and these layers are connected with colors, and if you want to look at colors according to these layers instead of the objects, you can go in the ExpressMarine window and select this radio button here, use colors from automatically generated layers. So if I click that, you will see we have a different set of colors now for our models, and we can change the color for example for a specific stiffener by finding that layer and change the color of that layer, for example from red to gold, and then all stiffeners of that type belonging to that layer will then get different color. So that's one way of doing it. Now there is another way also which has been added lately, and if we go back to this use item tree colors, I will show you that how to do basically the same but within the ExpressMarine window, and this has a couple of advantages. If we go back to the stiffeners and select this one and try to change the stiffeners of that particular type within ExpressMarine, I go to this stiffener stock node, and then I can define a color for this stiffener. I select the stiffener type and I select the color, and we had let's do the same, gold. And now every new stiffener that's going to be created of this type will be gold, but you can also apply it to existing stiffeners by simply clicking the apply button up here, and now we obtain the same effect here by getting golden stiffeners. And if you want to do it for another type, you just select another type of stiffeners, give it the color and so forth, but we just leave it for this one for now. Same if I go to plate stock and go and say that all my 8mm plate thickness will be of this blue color, so I can define that, and then I click apply, and now I can see all my 8mm plates turning blue here. So what is the advantage of doing this way compared to changing the layers? There are basically two advantages. One is that these ones you can also connect to a ship constructor plate name for the thickness, and for the stiffener stock you can connect it to a ship constructor stiffener. So if you are planning to export to ship constructor, this is a way of mapping up the stiffeners instead of mapping them up the usual way in default on each of the objects. So that's one advantage, and the other advantage has to do with templates, and I will get back to that, because this is one of many settings you can do in the project. But what's new is that you can now also save all your settings and start new project with these settings predefined. So color handling like this for plates and stiffeners is one type of setting. There's another type of setting. If you go to for example stiffener node here and deck stiffeners, here you can define default stiffeners to be applied to every deck that you create. In similar way you can create default stiffeners for transverse bulkheads and default stiffeners for longitudinal bulkheads. This is done the same way as you define it for an object. You select the node, click the plus sign, get the template going and select the type of stiffeners, and then you can add it. And this is a quicker way to build up the objects, because now going forward if you create a new object it will automatically get these default stiffener settings. This can also be appended on an existing project if you do it after you have defined the main objects without stiffeners. There's also some other general settings. One thing is that you can, if you put the colors like here, you can select to color the nodes in the tree by the item colors. So if you select this one, the nodes here will change colors to reflect the colors of the different that you've set for the different type of objects. Another way of node formatting is to not do it by the colors, but by selecting it by objects to set groups, for example, to give them bold. You can give a certain item certain color, and so forth. All of these are settings to try to make it easier for you to navigate in the tree. And some other settings here are like colors. I don't know if you noticed, but when we had this drop list with the colors, it by default has AutoCAD colors and named colors. Let me show you what I mean. For example, if we go to the plate stock here, the color, these numbers here are the AutoCAD colors, and then at the end we have these named colors. But that's a setting that you can go and say if you want to include AutoCAD colors or only Windows named color, for example. You do that as a setting. And a final setting is what's been mentioned already, that you can now rename any node. So for example, if you have a certain tier and you don't like the terminology tier, you can right click on the tier, say rename, and instead of tier 2 you can call this main deck. And same for tier 3 here. You can go to tier 3 and rename that to anything you want. You can call this, for example, the third deck. Then when you have defined your tree and define your colors and default stiffeners and other settings, then you can go to general settings and you can save this by creating a new template and then start a new project with that template. And this is how to do it. You select create new template, you store the template, you can call it for example webinar template, and save. And then when you start a new project, go to ExpressMarine new project, and we can close this one without saving. Down here you will see template, project templates, and the template that you saved will be found with the names. So we just saved a template called webinar template, and you will find that in this drop list now, and you can select that template and click apply, and then it's going to start a new project with that template. Okay, let's move on to the final topic, tips and tricks for effective modeling. And let's go back to our vessel again, and let's see how we can as effective as possible make some changes to this model. And now I'm not talking about parametric changes, but I'm going to show about how to copy and paste objects, and also how to copy definitions and set definitions to several objects at once. So one thing we've already touched upon is this this new functionality, which have duplicate, cut and copy. So for example, we can go to this deck plane here, and we can say that this should go from x larger than 2 and until 10, just to make a part deck, and then we can duplicate it, and then we can call this yeah, we can just call it part 2, and then we can change this to then go from 12 and all the way. So this is a way of changing the deck definitions, and duplicating it is just creating a copy right next to that. But we can now also take this one, right click it, say cut, and go down to deck 3 planes. If we wanted to move it here, select deck 3 planes, right click and select paste, and now we have got a copy of this down here, and we may have to put a different Z position for it, and then we can create it. So duplicating, cut and copy and paste objects is possible, but it's also possible to cut and paste definitions within an object. For example, if we go back to our deck 2 planes here, and instead of doing a duplicate, we just do add a deck plane. So adding a deck plane will give us an default deck plane without any stiffeners, definition or limits. But now if we want to copy something from this deck 2 plane 1, we can copy the limits, for example, by say copy all limits row, right clicking this, and then go down to deck plane 2, right click and say paste, and now it pastes in the same limits as the other deck. Similar way, we can go back to deck 2 plane 1, And if we want to copy stiffeners, for example, we have two ways of doing that. One is we can right click this one here and copy all stiffener definitions, or we can go down to a specific one and right click it and say copy definition. In this case there's only one, so it doesn't make any difference if we do one or the other. Then if we go to our new deck plane, we can paste this stiffener by right clicking, and then we have two options here. We can paste and append, which means that we're going to add it to whatever is here, or we can do paste and overwrite, which means remove what's there and only put in the copied definition. So this is how to do copying within the property sheet. And the final thing I wanted to show is how to make change to some many objects at one time, the properties of these objects. At the end of each of the nodes there's a checkbox. If you want to make changes to many objects, you can first select them by checking their checkboxes. In example, I can check this one to check all these deck planes in tier 2. Can go back here and check the deck planes in tier 1 and the deck planes in tier 3 and also in tier 4. So now I've checked those deck planes and they are all marked. Then I can go to the right here to update properties of selected items, and I can say that I want to make all of these objects 6 millimeters, and instead of steel I'm going to select aluminum. Now if I go down here now and click update properties, thickness 6 and aluminum will be set to all of these planes. You can see this plane now has thickness 10 and material steel. If I go here, this one have thickness 10, material steel. But if I now go and say set these here, click update properties, all nodes, all objects which are marked then get these new properties. So now this deck plane has thickness 6, material aluminum, and it's the same for all of these marked one. They now have all thickness 6 and material aluminum. And of course the weight and CG is automatically updated with these new properties. You can also change color and profiles and also ship constructor properties in the same way. Time is running fast, so the hour is up. Just want to say thank you for your attention, everyone. Any questions that we have not been able to answer during this webinar, we will try to follow up by email. If you'd like to get in contact for further information or a quote, please contact us at office@expressmarine3d.com. And we might also follow up with a survey after this. We'd love to hear back from you if you liked this webinar. If you didn't, why didn't you like it? If there's something else you would like to see on in future webinars and so forth. So thank you very much, and goodbye for now.